Okay, welcome. This is Chuck Ridgway. I am yep, my sound is unmuted. Wonderful. My name is Chuck Ridgway. I'm the one of the managers here at Horner Automation. And today we've got an exciting program for you. We're going to be covering an introduction to tag-based programming in Cscape. And as my partner in crime is going to join me here, Casey Gardner. How's it going today, Casey?
Hey, not too bad. How's it going,
Great.
Jack?
It's going well. Okay, well, getting back to our subject, one of the reasons why this is an important subject for Horner customers is because of the history of Cscape. So for those of you who aren't familiar with Horner, we are best known for our line of all-in-one controllers. Now, some companies call these PLCs plus HMIs. Others call them maybe even operator interfaces with built-in PLC. At Horner, we prefer the term all-in-one controller. And really, we were one of the pioneers in this product category back in the late 90s. And so by introducing a single piece of hardware that has control capability with built-in operator interface, built-in I/O, and some really advanced networking capability, we helped kind of set the standard for these products moving forward. Now, at the time we released the first all-in-one controllers, and our product is called OCS, Operator Control Station. At the time that happened, we thought it was really important to have a single software package that handled everything. So we thought it was important that you had one software package to configure every element of the application, including the way you build screens, configure your network, and of course, the way you do your logic. And because this was 1998, when we last developed that, or when we first developed that, I should say, we started out with what's called register-based or memory address-based programming, where every variable that you create in your program needs to be tied to a specific memory location within the software. So that is what is really known as register-based programming. Variable-based programming is a little more modern, and in that scenario, with variable-based programming, you no longer have to define every single, or you don't have to map every single variable to a built-in memory location. The software pretty much handles that on its own, and because of that, it's a lot easier, a lot more streamlined. Now, Casey's joined me again here. And Casey, you've got some experience with both tag-based and register-based. That's correct, right?
Yeah, I think starting out, I had a little more tag-based than I did register-based, but you kind of get a mix as you go along. And a lot of different manufacturers use one or the other or both in our case. So.
Yeah, and in our case, because we support both for a couple reasons. One is because we don't want to leave our existing customers stranded with older programs that with intellectual property that they can't bring forward to modern machines. That's one reason. Another is because of the fact that we've had the same software package that's been continuously upgraded between 1998 and 2021. So again, we've got a lot of users out there who are still using register-based programming. We're going to continue to support that, but we also want to expose you to variable-based programming as well. Okay, so let's get started with our demonstration. You're seeing my desktop right now, but let me go ahead and fire up Cscape. Okay, now what I'm looking at here is a really simple application where we're really just starting and stopping a motor. I've got a timer and a counter. There's not a whole lot going on here, but it's really just here to illustrate what we're talking about. So this is a program that was developed using the register-based programming style, the traditional register-based programming style. So you can yeah, go ahead.
Just a reminder to users out there, if you have any questions, feel free to pop them in the chat and we'll answer them as we're going along as well.
Exactly. That's one of the advantages of this live format, as opposed to our webinars, which is only quasi-live, in that we can react to questions as they occur a little bit better with this format. So we encourage you, if you have questions that come up, feel free to type them in. Casey's going to be keeping an eye out for them, and he'll interrupt me when he needs to, just like he just did. Okay, thanks, Casey. Okay, going back to this register-based program, you can see here that every element on the screen not only has a variable name, but also has a memory location. Okay, and that's because every time you place a programming element on the screen, at the very minimum, you have to define its memory location, and as an option, define the variable. Now, we've all looked at programs that didn't have enough documentation, so the last thing I would suggest is not to fill in the variable name here. But that's basically what you're looking at with a register-based program. And then we have a tool built into the register-based version of Cscape programming logic that's called the IO name editor. And with this tool, this is where you can see all the predefined variables for the project. And predefined variables include names for function keys and system bits and system registers, along with any other variables that have been created in the program. And you can use this tool to edit variables, to delete and add additional variables and that sort of thing. But you can also add variables on the fly as you add programming elements to your program. So you can definitely do that. Okay, now, again, this is a register-based program. Let's take a look at the same program, but now using tag-based tools in Cscape. And I want to reiterate, the same version of Cscape can support 3 different styles of control logic editing. Advanced ladder with registers, which I just described. Advanced ladder with tags, as I'm going to describe here now. And then also we support a full, pretty well standard IEC 51131 programming logic style that we'll cover in some other videos later on. But for today, we're going to really focus on the tag-based approach. So as you look at effectively what is this same program, you'll notice that you only see the variable names. You don't see any memory locations because for the most part, especially for internal variables, the memory location is irrelevant. You type the variable name in. If it doesn't have to be mapped to any specific memory location, then Cscape just takes care of it in the background. So really, it's a more modern approach to programming. Now, there still are some scenarios, however, where you do need to map variables to specific memory locations. The most common of those is when you're dealing with like direct digital and analog I/O. So as an example here, this first variable that's called start push button, that really needs to be mapped to a specific memory location, one that effectively is wired, if you will, to a specific digital input because we've got a hard push button there that we're dealing with. So with tag-based programming, we're dealing with not the IO name editor, but with the variable window. And I'm showing that here. So with the variable window, let me scroll all the way up to the top here. With the variable window, this is where all of our global variables, a lot of these are the predefined variables, you know, the system bits and system registers, those sorts of things. And any other variables that are created in the program, that's where those are listed. And they can be edited here. So they can be added here in advance. You can import them if you'd like. We won't cover that in this video, but that's another option. Again, you can make changes to them, etc., etc. Another option you have, and let's find that variable I've been talking about here. Here we go. Start push button. So we can see it's of a type Boolean, which makes sense, right? It's a push button. And you can see that we have mapped it, or tag as this says, we've mapped it to %I5. That's because that hardwired push button needs to be connected virtually to input number 5. So this is one of the scenarios where we do need to actually map a particular variable over to a particular memory location. But for the vast majority of these, you can see there is no entry here because it's not needed. The ones you're typically going to find are going to be ones that are tied to real-world I/O. Effectively then, there are other situations where you need to map variables to specific locations. And another example might be if you're going to share a variable outside of the application, maybe over Modbus or Modbus TCP protocol. Now, Modbus protocol is definitely a memory mapped or register-based protocol. And so in that scenario, if you want these variables to be accessible outside over Modbus, for instance, and in a typical application, it's only a small subset of your total variables, then you would want to map those as well. But again, we're not going to cover that directly in this particular video. All right, now let's start talking about some of the things that are a little more different, although not terribly different, between register-based and tag-based. Now, there are other features, which we're not going to cover today, which are a real advantage to tag-based programs. So that would include things like user-defined function blocks. Those are function blocks which you can kind of create using your own code. They're a little bit like subroutines, but really on steroids, really, because you can take what normally might be a subroutine, and a UDFB is similar, except there's a separate set of variables for every instance of that user-defined function block. So that's a real advantage or a feature that you can get with tag-based programming that you can't get with register-based programming. So there's a variety of reasons why you would want to modernize your programs. But again, for the most part, it's really, they're more alike than they are different. All right, let's start talking about timers and counters. All right, and I'm going to switch back to the register-based version of Cscape here. Now, for those of you who are familiar with the Horner OCS, you'll know that for timers and counters, we don't have a specific data type for timers and counters. What we do is we just allocate typically 2 words for a 16-bit timer. The first word is the accumulator, where the counts are incrementing, whether it's time counts or whether it's, unit counts in the case of a counter. So the first 16 bits, or the first register, if you will, is assigned to the accumulator. And then there's a second one that's implied, that's right next to it, that is assigned to the housekeeping register. Now I'm still in my tag-based editor here, which I didn't want to be. Let me go back to register-based here. There we go, that's better. Okay, so if I go into if I go into my register-based Cscape and take a look at my timer, I only have to define the accumulator register, but it's implied that register 2 is going to be my housekeeping register. So register 1 is my accumulator. It's implied the next register in line, which happens to be register 2 in this case, will be my housekeeping register. And that housekeeping register really doesn't have a lot of functionality for users, but there are a couple of flags, timer active and timer done, that can be found useful by some users. So we'll show you how those work as well. All right, but this is register-based timers. Let's go back to tag-based. Okay. All right, so with a tag-based timer, when I double click, sorry for that glitch there. When I double click and take a look here, all you have to define is the timer address or the timer variable name, okay? So you don't actually, there isn't an implied second register. Now when the OCS executes a timer, it still is needing one word for the accumulator and another word for a housekeeping register. So that requirement doesn't really change. So when you define a timer variable, it's more complicated than just a couple consecutive words from the standpoint of defining that variable. So with tag-based Cscape, we used what are called structures for complex type variables, which are an example of which would be timers and counters. So got a good question in that I just saw. I'm going to go ahead and stop and answer that right now. Okay, from John. I'm hopeful that with a future update, I can put the variable window on another screen with a different resolution. That doesn't play well with the current release. I want to assure you that that is the case. you will be able to do that in a future version of Cscape. That's something we're currently working on. So that's great feedback, John. Appreciate that. Another question that we got from Charles. I'll go ahead and show this on the screen here. Another question. I covered up Josh's name. That wasn't very nice of me. But anyway, can you convert register address program to a tag-based one? With Cscape 9.9 Service Pack 4, you will be able to do that. So that's good news. So in the very next release, which is due any day now or any week now, you will be able to convert from a register-based program to a tag-based one. Okay. All right. Let me go ahead and go back to our discussion on timers. So again, we were just starting to talk about structures. And you use a structure, and many of you are very familiar with these, especially if you've been doing tag-based programming. But just as a quick summary, you use a structure whenever the variable is more complicated than what you can define with just a simple single word or Boolean or character or whatever the case may be. Okay, so when I define this runtimer variable in tag-based Cscape, I need that variable not to be just a simple word type variable, but I need it actually to be let me go ahead and cancel here. I need it to be a variable based on a structure. And in Cscape, we have configured several different structures. Okay, and I'll show them here. We've got one for a 16-bit timer, another for a 32-bit timer, and then we also have one for the PID instruction, which is a way more complicated than just a couple of words. So if you take a look at the structure of a 16-bit timer, you'll see that we have one unsigned integer that is the accumulator, and then another unsigned integer that is the flags. So that would be the timer active and the timer done bits. Okay? So that structure is what you need to use when you're defining a new timer or counter. Okay. Now let me go ahead and illustrate something else here. Let's go ahead and create from scratch a new timer. And I think some of this will hit home a lot easier if I just show you a new timer that we create from scratch. Okay, so I'm going to go ahead. If you haven't noticed, what's really happening in this application is that we just got a simple start-stop circuit. And then we've got a timer that's timing how long the motor is running. And then we've got a counter that's counting the number of starts. Okay, pretty typical stuff. So let's go ahead and create, a new timer that times, that times how long the maximum number of starts bit has been on. So whenever we're counting starts, if we hit the preset, so let's say that after 5 starts, we need to wait a certain amount of time for the motor to cool off. When this timer when this counter reaches its preset, it's going to turn on this bit. So let's time how long this bit is on. Hey, I got another good question here. Oh, go ahead. Go ahead, Casey.
That's all I was going to mention is Wisconsin Converting's got a good question.
Well, why don't you go ahead and let us know what it is?
So he's asking, is there any possibility of custom structures or plans for IODD support?
Okay. Absolutely. We have a user-defined function block functionality that is available that you can use with tag-based programming. So hopefully that answered that question. Okay, so we're going to go ahead and create a new timer. Oh, looks like we're going to go ahead and create a new timer. Let's just go ahead and do that from scratch. So I'm going to place a contact on the screen. The contact I want to time is the alarm starts exceeded bit. So I can start typing that in. There it is. Hit OK. All right, I've dropped that contact on the screen. I'm creating a new run there by right-clicking. If I'd have dropped that contact in column A1, or I'm sorry, in column A, then it would have created the run automatically. Let's select a timer. Drop that on the screen. Okay. All right. Now, we're defining a new timer, and I'm going to go ahead and do it on the fly. Now, I could go down here into the variable editor and add it there, but in this case, I'm going to go ahead and add it on the fly. So let's go ahead and create a timer called restart timer. Okay. Now, since this is a new variable, anytime I'm creating a new variable, I need to press this arrow key here. And then this shows me all the existing variables that already exist. Well, this is brand new. So instead of selecting something from down here, I'm going to select the check mark. Okay. Now you'll notice that I've got my new variable called restart timer. You'll notice that Cscape has already filled in for the type the structure of timer counter 16. And if it was a 32-bit timer, I could just on this pull down list select that instead. So that's what I want. So I'm creating a new timer of the type timer counter 16. I'm going to go ahead and make it part of the retained variable pool, okay, instead of global, and hit yes. All right. I'm also going to go ahead and make this timer retentive. So that means that it, on a power cycle, it's going to remember where it was effectively, or more importantly, when it loses when the timer goes away, it won't reset to 0 automatically. Okay. We also need to define a couple more variables, including a set point. So let's call that restart timer. Do we have a question coming up there,
Yep.
Casey?
I was going to say we had a comment from John, which I could follow up with him regarding some data he might have been seeing in the data watch window.
Okay.
And then we also have a question from Charles asking about the new tag-based variable table support mass imports from a copy and paste, like through Excel, I imagine, which I'm sure, as you would confirm, that that's definitely the case in future versions.
Sure. So we mentioned, or maybe I forgot to mention, that you have the ability to import and export I/O names into the register-based version of Cscape to and from Excel. You can do the same thing with the variable-based or tag-based Cscape. It's just more complicated. So that's one of the things we're really working on simplifying. But keep your eye open for just a short video on our YouTube channel at some time in the very near future that describes the procedure for importing your variables into the tag-based version of Cscape. Because it's in there today, it's just a little more complicated. So we'll post a video on that. Meanwhile, we will go to work on making it a simpler process. Okay.
It looks like we just got another one as well.
Okay, go ahead.
This is from Nigel Bradbury. He's asking, when changing coded data format from int to dint/real, then 2 words are required to be allocated. How does this affect register map memory order in tag? My pain is reordering register order renumbering.
Okay, so is he talking about variables that are automatically mapped by Cscape in tag-based Cscape, or is he talking about variables that may be manually mapped? I guess I'm not sure. We may need to follow up on that. Okay, let me go ahead and just finish up this part of the demonstration here. So again, what we've done is we've created a new timer called restart timer. We're going to allocate a new variable that is the set point for, and we don't want it called restart timer. We want it called restart set point. There we go. That's better. Looks like I can't spell. Okay, there we go. Again, it's a new variable. I'll hit the right arrow. All right, it's a new variable. I'll hit the check mark. Unsigned integer, we want this to be retained as well. All right, I hit yes. All right, the last thing is a reset. Okay, so let me go ahead and create a new variable here. Again, I'm doing this all on the fly. I could do it in the variable editor. I could also import it from a spreadsheet or something. Let's call it reset. Let's see. This isn't the run timer. This is the cool timer. There we go. This is a Boolean bit. All right, we don't care about it being retained, so everything else is fine. We'll hit OK there, OK there. All right, so And this isn't a glitch in Cscape. This is a glitch in my computer. There are certain situations where my computer, I guess, might be running low on memory or something. So it's taking a minute to redraw this. But again, this isn't Cscape's fault. This is my computer. So it should be back here shortly. Okay, so what we've just done is we have added a new timer to the register-based version, I'm sorry, to the tag-based version of Cscape, and you saw that process that we followed to do that. All right, so the next thing we're going to want to do, hopefully when Cscape gets done redrawing here, and again, it's not Cscape's fault, it's my computer. I've got a memory issue I've got to get fixed before the next live event. But anyway, the next thing we're going to want to do is we're going to want to access some of the flag bits within the housekeeping register or the flag register for the timer that we just defined. So let's go ahead and do this. We've just defined a timer that basically says that while it's timing, we don't want to be running our motor. So let's go ahead up here to that first rung, and let's go ahead and let me delete this. Okay, let's go ahead and put in a contact in the rung in the rung here that will prevent this motor from running if we're in the process of cooling down the motor. And what I'm going to put in here is going to be the timer active flag for that cool down timer, so that if that timer's timing, then we know we shouldn't be running the motor. So this is one way of accomplishing this. So I'm not creating a new variable here. I'm just effectively navigating to an existing one. So I'll hit the right arrow and pull up the variable list. And then I'll take a look for the, let's see, what am I looking for here? I'm looking for my timer. Let's see, let's see, run timer. I don't want that one. It's the restart timer. There we go. Took me a second to find it. My apologies. So under restart timer, I'm going to go ahead and select the flags element to the restart timer. So I've done that. Now, the specific flag that I'm interested in happens to be the 15th bit of the flag, is the 15th bit. So I'm going to put dot 15 here to represent the timer active bit in Cscape. Okay. All right. So I should be able to just hit enter here and enter there. Okay. And again, my apologies with my computer taking a little while to rewrite. We'll get that corrected before the next event. But what I've just done there is I've accessed the timer active bit in that timer structure by accessing the 15th bit of the flag element. And now that will interrupt the run contact, so my motor won't run while it's supposed to be cooling off. Okay, so that's timers and counters. One other last thing that I want to mention is, and this is really more similar than it is different. One other thing I want to mention is the ability to take these variables and put them on your screen when you're creating screens, for instance. And that's really, like I just said, it's really more similar than it is different in terms of the way you do it between register-based and tag-based. Looks like we got a question there, Casey.
Yeah, we got a number of them actually. So Charles has a few that we can go through.
Okay.
This first one is, does the new tag-based system support arrays?
Yes, absolutely. No question. That's an easy one.
Yep. And that's in Service Pack 3 for the existing versions. So
Exactly.
then the second question is, does the new tag-based system support user-defined variable arrays? And does it support indexing with a variable of an array?
I believe so, but that's one I'd like to follow up on. So we'll have Casey follow up on that. That's a great question. I'll make sure that I have the right answer for that.
Absolutely. So then he also has an extended question from that. So then, in the same way user-defined variables or objects can be created any future or ability to do the same with Cscape graphics?
Yes.
Which,
Yeah.
yes.
That's definitely, it's not, you're not going to find it in Service Pack 4, but it's definitely something that's in the works for Cscape 10 and beyond. Okay.
And then we
Go
also
ahead.
have one more question we'll get in here real quick. So Wisconsin Converting is asking any value in expanding the dot numbers to be more intuitive. If they are predetermined bit positions, expanding the tree under flags to include the 16-bit positions, but as the named versions of the flags, which I believe are taken care of in our structures for the timers and counters. Is that correct?
I think what he's saying is, since I just had to explain that the 15th bit of the flag register was the flag element was the active bit, and the 16th was the done bit.
I got
Those really should be something we pick off a list instead of having to remember that it's 15 and 16. Agree 100%. We'll get there. It's just not there today. Thanks. Good suggestion. Okay, let me go ahead and now just kind of wrap up this demonstration here. So what I was just starting to go through was, how is register base and tag base similar or different when it comes to actually putting data on the screen? Well, it's almost identical, but let's just go ahead and go through it anyway. So let's just start with register based. Most of you are very familiar with register based, in Cscape at least. So I'm going to go ahead and pull up the screen editor here. And you'll notice that whenever we put objects on the screen, that we, whether it's a brand new object, whatever the case may be, that we have the ability to either type in the memory reference, or to type in the variable name, or to pull the variable name off the list. And technically it's an IO name if we're talking register-based Cscape. Okay, so that's pretty obvious. That's how Cscape has always worked. Okay, and variable base is really very, very similar. Okay, so let's go ahead and switch to tag-based version of Cscape here. And again, it's the same software packages. I just have 2 instances going so I can have a different desktop setup for each. That'll be corrected with Cscape 10. All right, now I'm going to go ahead and pull up the screen editor. All right, let's go ahead and go through the process of putting an object on the screen here and assigning a variable to it. That'll probably be the most informative approach. So what I'm going to do is I'm going to put a numeric object on the screen that allows us to effectively edit the amount of time we're going to allow that motor to cool down. Okay, so I'm going to pick a numeric object, but a specific type of numeric object, in this case, one that can effectively interpret timer and counter data directly. Okay, so that is a timer data property. Okay, so what I'm going to do now, let's go ahead and configure the object, then I'll select my register. So I'll justify it as center justified. Let's make the text a little bit bigger. Okay, we want to see seconds. Okay, so yeah, we'll go ahead and say we're going to want to see seconds. And the format, let's just make it minutes and seconds. All right, instead of it being just seconds or just minutes. All right, let's give it a legend. Let's call it cool down preset. Bump up the size a little bit. Okay, and all this is just the same regardless of what version of Cscape you're using, of course. And again, sorry, my apologies, waiting on my computer to paint. All right, now let's go ahead and pick our variable. So the easiest way to do this, I think, is just to go ahead and hit this little right arrow key and pull up the tag browser or the variable browser. And it's only going to pull up integer-based variables. So I'm interested in my restart timer. Okay, I believe that's what I'm looking at, right? Yep, restart timer. Okay, and in this case, I believe I'm interested in the accumulator. Okay. Okay, let me hit OK. There we go. All right, so that's really all there was to it. Basically, the main difference is you've got this variable browser that we didn't really have as an option in register base. There you just kind of look at the list of variables Here is you've got a few more options in terms of the way you browse those, and it's in more of a tree form. Okay, so that's, again, they're more similar than different. That's taking a look at tag-based versus register-based. Okay, so that pretty much wraps up what I wanted to cover today. Again, this was an introduction. We got some great questions from the guys and gals. A lot of them related to slightly more advanced topics that we will definitely get covered for sure. But again, thanks for all these great questions. I'm going to go ahead and let's go ahead and bring Casey back in here. Okay, Casey. Thanks for being the moderator, keeping me from crashing into the iceberg. Looks like we might have another question. What do we got there?
Yeah, so John is asking, is there a reference document that goes in a deep dive into the data behind the data, like the flags of the timer counter 16?
So we do have the way we've traditionally done that has been with the help file. So let me talk a little bit about the help file. So the last version of an actual physical document that we had for Cscape has been years ago. So pretty much all the documentation is in the help file. Now, with Cscape 10, which will be available, again, relatively early this upcoming year, let's say mid-year at the latest, for Cscape 10, we have a completely rewritten from scratch help file that'll be available in a variety of forms, including HTML. It's going to have a lot of links to videos for the ability to see or to get the help through a video form and that sort of thing. But for now, in terms of the way to get information that, like you're asking, pretty much you have to navigate the help file today. Okay.
Yep, absolutely. And keep in mind, it's features we do have a lot of implemented in today's Cscape. We are definitely working constantly on upgrading the user experience to make it more and more helpful for the future.
Absolutely. Casey and I are just two of a bunch of guys and gals that have been, meeting once or twice a week, really for 6 to 9 months now, working on the new Cscape in terms of what we want the user experience to be, taking the feedback we've already gotten from great users like yourselves, and incorporating that into these new versions of Cscape. So I really, we really want you to know that there's a ton of effort going into the background trying to get Cscape 10 just as good a user experience as we can. Okay, thing I want. Go ahead.
Oh, I got one more question we popped
Sure.
in. Charles is asking, can you map your tag-based dedicated registers if desired, namely for things like Modbus? So I believe Chuck went into it a little bit earlier in the stream, but in your variable table, you have what's currently called a tag list in the variables. We probably will be changing that to try to make it a little less confusing in the future. But yes, you can absolutely assign variables to specific memory locations to help make things, especially things like Modbus or I/O specifically, more accessible.
Absolutely. Yeah, and you do it in this column right here. So if I have this start counter, well, that's a bad example. Let's take a look at this start preset. This is an unsigned integer. That's the preset for, it's a preset variable. So it's an unsigned integer. If I want that to be mapped to a specific location for Modbus purposes, I can do that right here, for example. Let's say that I want that to show up automatically, and I'm not going to go into too much detail, but let's say I want that to show up automatically under a certain Modbus address. There's a fixed map between a Horner address space and Modbus address space. So you'd have the ability to put that memory location right there and tag that variable where you want it. So you definitely have that capability. Okay, let's go ahead and wrap up now. One thing I want to make sure I mention is that next week, same time, we've got another session where we're going to be talking about temperature sensors. So RTDs, thermocouples, and thermistors. What are they? How do they work? How do you connect them to Horner controllers? I mean, really, even if you use all kinds of other companies' products in addition to Horner products, we think there'll be some good information for you here. Some good tips and tricks on what make different temperature sensors effective, which ones to choose in which applications, all that sort of good information. So join us next week, same time, and we'll do our best to get you some good information. Take care.